Hello, my dear students. I welcome you once again to this current lecture. In the last lecture, we started the important point from the chapter that is called as the application of this phase rule for the various components of system. So among that, we started the first component that is called as the one component system, and in that we studied the phase diagram for the water system. So, how the phase rule is important for describing completely the water system, that we already studied with the help of the phase diagram. How this phase diagram is useful for describing that water system, so that we completed in the last lecture. After that, in the current lecture, we have to start now the second component system, that is called as the two component system. Before that, in the last lecture, we take only one system belonging to one component system, that is called as the water system. Next to the water system, the sulfur system is also there. So you do it as a homework, that is a sulfur system. So next to that, today we are going to take the next two component system, and in that two component system we have to study specifically the lead silver system. So this is a second type of the phase diagram we have to study in this current lecture, that is a lead silver system. Before that, we know very well that what is the meaning of this two component system, that is the two components chemical compositions are required in order to describe completely the given system. So that is a two component system. So the two component system which we are going to study is called as the lead silver system. So before studying this phase diagram for this lead silver system, we have to consider, whenever we consider the two component system in describing the system completely, suppose if the phases present, suppose this two component system having the value of C is equal to 2, the value of this C is equal to 2, and suppose if the one phase is present in this two component system, suppose the value of this phase is equal to 1, suppose. So if we use our regular phase rule equation, F is equal to C minus P plus 2. Now if we substitute the values for this C, this P, and if we solve this simple equation, just we substitute here value of component is equal to 2, value of phase is equal to 1, and if we solve this simple equation, the value of degrees of freedom comes out to be this F is comes out to be equal to 3. So we can say that if we suppose consider the two component system having the degree number of phases is equal to 1, and if we substitute these values in a given equation of phase rule, the value of degrees of freedom comes out to be equal to 3. So we can say that whenever we take such a type of the 3 degrees of freedom, so at that time we have to use the 3 coordinate axis system in order to describe the system completely. But what happens, by the use of this 3 coordinate system is somewhat tedious, and that's why to avoid this we consider here only the two coordinate system, and that's why we take into consideration just the two variables among, either you take here temperature or pressure or the concentration. So just we take here any one of the two variables for describing the system completely, and that's why in such a type of the situations we have to use the second type of the phase rule, and that is called as the reduced form of phase rule. That is a reduced form of phase rule. This is the reduced form of phase rule, or that is a reduced form of phase equation is there. So in this situation we use the equation like this: F dash is equal to C minus P plus 1. So that type of equation we have to use in such a type of the systems belonging to the two component system. So it is a very important part before studying this type of the two component system. Means we can say that if we use the regular phase rule equation, by using that, if we take the value of C is equal to 2, phase is equal to 1, then the degrees of freedom comes out to be equal to 3. So in such a type of the situation, we have to use the 3 coordinate axis system. But to avoid this, we can use the reduced form of the phase rule equation, that is nothing but the f dash is equal to c minus p plus 1. So this equation we have to follow in order to calculate degrees of freedom for such a type of the phase diagram for two component system. So this is a important point we have to keep in your mind before studying this phase diagram. Now, after considering this type of the reduced phase rule equation for this two component system, now we have to focus our attention towards this type of the phase diagram for this two component system, that is the lead silver system. So this figure is called as the phase diagram for the lead silver system. Now, as far as this phase diagram of lead silver system is considered, so we can say that in this particular phase diagram, different type of areas, different type of the curves or lines are to be present, different type of the points are to be present. Then what are the importance of all these areas, curves and the points, that we have to study one by one in the same manner in which we studied the water system. So first of all, as far as this phase diagram of lead silver system is considered, in which we have to take into consideration two variables into consideration. The first variable is called as the temperature of the system. So that temperature we have to take in a unit of degree Celsius. So this is the first variable. The second important variable we take into consideration here, that is called as the concentration, or we may tell it as a composition. So these two variables we have to keep in your mind for describing this lead silver system. One is the temperature, second is called as the composition. After that, before studying this particular lead silver system, we again keep in our mind, in this case we take into consideration the composition. Now this composition is belongs to the percentage of the two different elements. One is called as the lead and second is called as the silver. So it is a mixture of lead and silver. That's why in such a type of the cases we take here composition. So what is the composition of the particular system at a given temperature? So that's why we take here into consideration the composition. So this phase diagram consists of the three important parts. It consists of the three important parts in this system. The first important part is called as the areas. The first important part is called as the areas. The first important part is called as the areas. So how many types of areas are to be present, that we have to study here. So as far as the first important part areas are to be considered, so if we look towards the figure, it has the different type of the areas. The first important area is called as the area above A, C and B. The area above A, C and B. This is the first important area. First is area above A, C, B. So this is the first important area we have to study first. Now as far as this area above ACB is considered, so if we look towards this figure, the area above this A, C and B, it consists of one phase, and that phase is called as the liquid phase, in which this lead and silver are to be present. So we can say that as far as this area above ACB is considered, in which the number of phases is equal to 1. In this case, we can write here phases, that is a P is equal to 1. Now, if we use this value of P is equal to 1, we already know that this is a two component system. Now, if we apply the reduced phase rule equation, that is F dash is equal to C minus P plus 1, not the 2. In this case, we have to take here 1 because it is a reduced form of phase rule equation. Now, if we insert these particular values, component is equal to 2, phases is equal to 1 plus 1. So what happens? That F dash is comes out to be equal to 2 here. The F dash comes out to be equal to 2, and that's how you can say here So we can say here this type of the degrees of freedom is obtained for such a type of the area above ACB. So in this case phases is equal to 1. So by using this reduced form of phase rule equation, we get here degrees of freedom is equal to 2. So we can say that whether we want to study this area above ACB, we require the two variables, we take into consideration two variables. That's why the system present in this particular area is called as the bivariant system. So this is the first important area above ACB. Now after that, the next important areas are to be there. So next important area is called as the area below line AC, area below the line AC. This is the second important area. So we take here second important area below AC, A and point C. So this is the next important area below AC. The next is there area below, the next is the area below BC, this B and point C. So this is the third important area below BC. Now as far as these next two areas are to be considered, now we have to consider both these areas simultaneously. First area is the area below A and C. Now if we look towards the area below A and C, we get one hint that if we look toward its composition, it has the two type of the phases. The first important phase is a solid silver. Below this area AC, the first phase present is called as a solid silver, and the second phase which is to be present is called as the solution. What is the solution? It is a solution of this lead and silver. So we can say that below this area AC, two phases are present. In the same way, below the area BC, again how many phases are present? So first phase is called as the solid lead. This solid lead is there, and second is called as a solution of silver and lead is there. So again below this area BC also two type of the phases are present. So we can say that for both these areas, the value of phases is equal to 2, and that's why if we calculate its degrees of freedom, that is f dash is equal to component is equal to 2 minus phases is equal to again 2 plus 1. So in this case the value of f dash comes out to be equal to 1. So you can say that if we want to study the systems below the area A, C as well as area below B and C is called as the monovariant system. It's called as the monovariant system because value of f dash comes out to be equal to 1. So these systems are called as the monovariant system. After that, the next important area is there in this phase diagram, that is called as the area below the temperature of 303, that is this downward area is there. In this downward area the phases are present, that is called as the solid silver and that is a lead is there. So this type of the four important areas are present in this phase diagram. These are four different areas are. The first area is called as the area above ACB, having only one of the phase, that's why its degrees of freedom is equal to 2. So that is called as the bivariant system. The second and third important areas are area below AC and area below BC. So these areas having the phases equal to 2. So these areas are called as the it is a monovariant system, that is called as the monovariant system. And the fourth important area is the area below the temperature 303 degree centigrade. So in this way, these are the first important part of this phase diagram for silver lead system, that is called as the areas. Now after that we have to consider the second important part, that is called as the curves. How many curves are present in this particular phase diagram? So that we have to study now. Second important part is the curves, or we may call it as a lines. Curves, or it may be called as the lines. Now as far as this figure is considered, it has the two different type of the curves or lines. We can say that the first curve is a curve AC. This is the first important curve, that is curve AC is there. The first important curve or line is a line AC, or it may called as a curve AC. Now, as far as this line or curve AC is to be considered, so this line or curve is called as the freezing point curve. It is called as the freezing point curve, or it is called as the melting point curve. It is the freezing point or melting point or melting point curve of silver. It is the melting point or freezing point curve of the silver. So we can say that whenever we consider the first important line or curve, that is line AC, it is called as the freezing point or melting point curve of the, that is a silver. So in this case, the melting point of the silver is equal to 961 degree centigrade. Now, if we go along the line, along the curve AC, what happens if we go from point A towards this point C? What happens? The melting point or that particular freezing point of this silver get lowered or get decreased due to the addition of the particular element called as lead. If we go along the line AC, what happens? The melting point or the freezing point of this silver undergo decreasing, or it decreases due to the addition of the element called as the lead. Now, along this line AC or the curve AC, how many phases are in a equilibrium with each other? So, if we look toward this particular line AC, what happens? Two different type of the phases are in a equilibrium. The first important phase is called as the liquid phase. This is a liquid phase is in a equilibrium with, that is called as the solid silver. So these two type of the phases are present in a particular this line or this particular curves. So we can say that phases in a equilibrium along this line AC is equal to 2. That's why in this case the phases is equal to 2. Component we already know here, that is equal to 2 here. So if we solve now this degrees of freedom value for such a type of the system, then what happens? This f dash is equal to component is equal to 2, and this phases again equal to 2 plus 1. So this f dash comes out to be equal to 1. So you can say that the system belonging to such a type of the curves or present on such a type of the curves, that is a line AC, is called as the monovariant system. So the curves AC or the line AC, the system in which present is called as the monovariant system, and we in this system the two type of the phases are in equilibrium. One is called as a liquid phase and second is called as the solid phase of this particular silver. So this is the first important curve or line present in this particular phase diagram of the silver lead system. The second important second important curves for this phase diagram is called as, second important curve or line is called as the line, that is a line BC. This is called as the line BC. Now, this line BC is now called as the freezing point curve. It is the freezing point curve of the element called as the lead. Why it is a freezing point curve of the lead? Because if we look toward its composition, the composition of this site is a 100% of lead is there. That's why it is called as a freezing point curve of the lead. While going from the point B towards this point C, we can say that the freezing point or the melting point of this lead going on decreasing with the addition of the element silver. So, along going from the point B towards the C, freezing point or melting point of silver going on decreasing. Again, if we look towards how many phases are in equilibrium along this line BC, so again we can say here the two type of the phases are in equilibrium. The first phase is called as the solid lead is in equilibrium with the liquid or the solution of silver and lead. So again in this line BC, the phases are equal to 2. and so we can say that in this case also that f dash comes out to be equal to 1. So again we can say that the system present on this curve or line BC is called as the monovariant system. So both the systems present either on line AC as well as line BC are called as the monovariant system because they consist of the two phases in equilibrium, and that's why the value of this f dash comes out to be equal to 1. So both these systems are called as the monovariant system. So these two important phases curves are present in this particular phase diagram, that is a line AC is there and line BC is there. Now after this, the next important part present in this particular phase diagram of this particular lead silo system is called as the eutectic point. It is the eutectic point is there. Now, what is the meaning of this eutectic point? So, we studied already the water system. In this water system, one point is there, and that point is called as a triple point. So, we know very well that triple point is present in a water system, that is a one component system, the point at which the three different type of the phases are in a equilibrium, and that's why that point is called as a triple point in a water system, that is a one component system. Now, as far as this two component system is considered, and especially lead silver system is considered, if we look towards its phase diagram, so what happens? The point C is there, this point C is there. This point C is called as the eutectic point. It is a eutectic point, it is not a triple point. So it has a special name called as the eutectic point. Now what is meant by eutectic point? So when the two lines or when the two curves, the line AC and the line BC intersects, when these two lines intersects at a point called as the capital C is there. So at this point these two lines get intersects, and due to which what happens, three different phases are in a equilibrium with each other. What are that three phases? One is called as a liquid is in a equilibrium with the solid, and the solid is in a equilibrium with this particular liquid is in equilibrium with the solid silver, it is in equilibrium with the solid lead. So these are three phases are in equilibrium at this point C, and that's why such a point is called as the eutectic point. So at this eutectic point we can say that these phases are equal to 3. The phases are equal to 3, components are again equal to 2. Now if we use such a type of the values of phases and components, and if we insert it in a reducer phase rule equation, f dash is equal to c minus p plus 1. So what is the value for this f dash? It is a 2 minus 3 plus 1, and finally value of this f dash is equal to 0. The value of this f dash is equal to 0. So we can say that whenever we take into consideration the eutectic point in this particular lead silver system, at which three different phases are in a equilibrium with each other, and that's why if we substitute these values in a reducer phase rule equation, the value for this f comes out to be 0, and that's why this system at eutectic point is called as the non-variant system, and such a system is obtained only at the fixed value of it is obtained only at a fixed value of temperature. It must be equal to 303 degrees centigrade, as well as a fixed composition. That composition is in which 97.5% of lead is present and 2.5% of silver is present. So we can say that this eutectic point has a system called as a non-variant. Why it is non-variant? Because it occur or obtain at a fixed value of temperature as well as the composition. So this is the importance of this particular eutectic point. Now at this situation, we studied here the three important parts present in this particular phase diagram. First is called as areas, second is called as curves or lines, and next is called as the eutectic point. So this eutectic point is very important. This eutectic point is very important as far as this phase diagram is to be considered. So whenever we consider this eutectic point, what happens? Suppose if we consider this point C, three phases are to be in a equilibrium with each other. So this is a eutectic point. Now as we go from point X toward this point Y, what happens? While going from X toward this point Y, we decrease the temperature. we decrease the temperature. So in this point X, what happens? A liquid phase is present. In this case, a liquid phase is present. But whenever we go gradually toward this point Y, along this Y or at this point Y, what happens? This Y lies on a line B and C, and along this point Y, a equilibrium is present between the liquid phase to that of the solid phase, and that's why we can say that such a type of the variation in the temperature changes the equilibrium between the phases as well as their degrees of freedom. So this is a description of the phase diagram for the silver lead system, in which the three important parts which we already studied here, the areas. So four different areas are to be present. The first important area is area above ACB. Second area is the area below line AC. Third area is the area below line BC, and the fourth important area is the area below the temperature 303 Kelvin, sorry, Celsius. The second important part is called as the line or curves. So two important curves or lines are there, line AC, and second is called as a line BC. And the third important part is their eutectic point. So this eutectic point is such a point in which three different phases are in equilibrium with each other. So we can say that in this eutectic point, the system is called as the non-variant system, and this system is obtained only at the fixed value of temperature as well as the fixed composition of lead and silver. So this is an important two component system called as the lead silver system. In a similar way, the second system is also there, that is a second phase diagram for the second important system, that is called as the zinc cadmium system. Zinc cadmium system. So this is another type of the two component system. So for this system, again a phase diagram is there. So that phase diagram you can study as a homework. So with this we take into consideration here, today we consider here the only one of the phase diagram for the system called as the lead silver system. The remaining, the second system, that is a zinc cadmium system, you do as a homework. So in a summary, we can say that in a previous lecture we take a first system, that is a one component system called as the water system, and in our today's lecture we take here lead silver system belonging to the two component system. So in both these cases we take into consideration the common parameters, we take into consideration the areas, the curves, and the triple points or eutectic point. In a similar way you can do the two different homeworks. One is a sulfur system from a one component system, and the zinc cadmium system from the two component system. So today I stop here with the description of this particular important part, lead silver system. Remaining points we will take in a next lecture. So with this I stop here. Thank you so much.